Okay. You hesitate at all about which one goes in where? It's a G of an f of x, so we put the f of x inside the G.
Yeah.
No hesitation, Ash? So, now I'm not going to hesitate. We put the f of x inside the G. So now we've got G of f of x. Do you prefer to write that way, or do you do G bracket, or what do you do?
I just do,
Yeah, doesn't matter which way you go.
I do just GFX.
Yeah. And you know what's really obvious about that thing there? The domain of range 16 minus 20 over x has to be greater than or equal to naught. Remember, it can be equal to naught. This is not a denominator. What's the quickest way? I think of moving that over there. It's always debatable which one's the quickest. And what do? Swap places. I think as Ash, I was talking to you about that one time. And you would go and divide by 20 or something.
Yeah, I was thinking that as well. So.
Yeah, could go cross multiply and all that sort of stuff. Nah, it's a waste. And what I think I nagged about in the past was I'd go swap places. Only if it's one fraction with one fraction, they can swap places. Or you can cross multiply. So that'd be 20 times 1. So x is greater than or equal to 5 and 4. Yeah? What's the big thing that makes this question different to everything else we've done like it? I'm going to write it properly. Denominator on, I've been thinking of how to say this there, on the inside of the, well, we could say of the square root. So what's your brain do the moment I draw that to your attention? You know, I sometimes talk about this. What am I saying? What have you not said about that x as yet that hasn't passed your brain?
It has to be less than.
Can it be negative?
Yes. Yeah.
Oh, it can.
And see, that never passed your brain. So what I'm doing, I'm glad we're doing this now, but I want it to pass your brain. So it's an extra level of complexity within the square root. So I've been thinking, how the hell do I say, oh,
it's one of those two rule questions.
So if that's a negative on a negative is a positive, so we can use any negative x value. Certain yet?
Yep. So x equals greater or equal to 5 over 4 or less than 0.
Less than 0.
Which you could.
Can't include 0, can you?
No. X.
The domain is
It's not affected.
the set of values for x are elements of the reals.
Yep.
Such that x has to be greater than or equal to 5 and 4, or x is less than 0. So that's about as fussy as you can get. Now, that doesn't tell us the range. So domain's usually easy, range is, it's always hard to say harder, it's trickier, more time consuming, you can do all sorts of weird things with it. What have we got? So what happens when we had x equals 0?
Doesn't exist.
Doesn't exist.
So that's an asymptote?
What happens if x was 1?
It doesn't exist.
Doesn't exist. We had x was 2. 16 minus 20 on 2, 16 minus 10 is 6.
Yeah.
So really at that point, here's where I nag about at 2, we're at root 6. If I went 1, 2, 3, 4, and I get a little bit fussy, go 2, 4. Root 6 is bigger than 2, smaller than 3.
It'd be about 2.3 maybe?
What if you said 2.4? Who cares? Let's say rough. So what have we got? 2.4. Do we want it? So by the way, let's go back to the 5 and 4. 2.4.
4.9.
So 5.4 would, 5 on 4 would be 0. So we know we got that there, about there. If it was me in the basic exam, I think I'd write it underneath that 5 on 4. What goes on then? Now, everyone then will go 2, 3, 4, and they go, nah, let's go big. Let's go 100. So what we have, square root is 16 minus 20 on 100.
0.2.
And then my brain instantly goes, what if it was 1,000? Then my brain goes, what if it was 10,000?
So it'll be approaching, as y approaches infinity,
As x approaches
x
infinity.
approaches infinity, y approaches 4.
Yes, in other words, this bit here becomes insignificant.
Yeah.
So we're approaching 4 from underneath.
Mm.
So now can I just put an asymptote across?
Pretty much, yeah.
4. And at that point in time, I know I can't go any further down, so I go there like that. Was that a bit rough? See, they look at the shape of the curve and you go, ugh, and then you muck around, you know, if you've got an eraser and you go, oh, I want it a bit more curved. And then, by the way, if it's got that there as 10, so 3, 4, 5, 6, 7, 8, say that was 9. Really, if you've got a reasonable point there, that would be handy if you had time.
Mm.
But you've got no doubt it's going to be pretty close by then. So what would that be? That would be 16 minus 20 on 9. Yeah? You know it's going to be up there anyway. So I would always go to the edge of the graph and get to about there. And what I expect them to do, and I'll do with you, or you've seen me do with marking your assessments, I'll go, yeah, somewhere around there. But if you had it down here, you're going to lose a mark. It was too rough. Starting to see the range? See half the range. So what's it now, the other side? Do we want to look for nice numbers? What about this one? What about x is, and I'm not doing it formally, I'm doing it almost like we're not doing up a set of tables. If x was -1, that'd be the most obvious to me. What do we have?
36.
Yeah, 16 minus 20 on -1, which turned out really nice, square root of 36, which is 6, but -1. We go all the way up there. At that point, what if you then had 3 seconds left and you just went like that? Yeah? If it said draw the graph, but this didn't say draw the graph. The question's done, other than we haven't written the range formally. You ready? We go for it? Formally. The range is curly brackets, y are elements of.
Real. Can I go 4?
Good.
Union
What are you going to say?
y bigger than or equal to 0.
Y bigger than or equal to 0. Because it goes past that and covers everything from there upwards. So like if I had a different colour pen it'd be better. But you see it now, don't you?
Mm.
So in other words, we're covered everything from there upwards, except for that point, and you're totally right. Curly brackets are done.